sessions. So the first session will be about access quality of data using AWS Glue data quality for ETL pipelines. This will be taken by Arun Kumar, Nagaraj and Naveen B. Both are from Presidio. Naveen is a lead data engineer at Presidio. He has more than 4 years of experience in working as a fast-paced agile developer with big data environment to quickly analyze, develop and tech potential use cases for business, giving continuous approach on improving the work with logical enthusiasm. He is known for being an adaptive and providing quick decision in regard with any situation. Naveen is skilled in Python, PySpark, AWS services and SQL. We welcome you, Naveen. Arun is a lead data engineer at Presidio with 8 years of experience on AWS cloud technologies. He works on designing and developing the data pipelines for streaming as well as batch processing as prescribed by AWS best practices. He also worked on designing the data pipelines architecture for a new product that quickly scaled from 0 to 125,000 daily active users. He is also a blockchain enthusiast. We welcome you, Arun.
Yeah, thanks. Hello, hello. Yeah, thanks for the warm welcome. Yeah, hope you guys had a great lunch. Uh, so yeah, so we'll start up with this. Today our topic is assessing the quality of the data, and also we are going to understand how data quality is important. That is the main agenda of today's session. And to start, to give a brief intro about us. So myself, Arun Kumar Nagaraj, working as a lead engineer at Presidio. I have around 8+ years of experience, and I'm keenly looking to contribute to the community and also get knowledge from the community. And also along with me, I have my colleague. He will be introducing.
Okay. So yeah, I'm Naveen Chandar B. As you all know, like I'm also from Presidio as a lead engineer. I have 5+ years of experience. I'm basically a data and DevOps enthusiast, and also I've not recently, more like 2 times I've become a community builder as well. So this is most likely we would like to cover what data quality is and how it's going to be impacting us on our organizational and on our revenues as well. So yeah, without further ado, so this is going to be our agenda for the day. As I said before, like why data quality is really important for us and how Glue is going to help us with that data quality being implemented formlessly on our ETL structures, data warehouses and storage and everything else. And apart from that, we will be deep diving into it with our key terminologies and then the features that will be provided by Glue itself. And then how we have like 2 set of important, let's say, features that's going to be REST and in transit for data quality in the Glue. We will be deep diving it later on, but this is like our key features. And when it comes to data quality on Glue. And apart from that, we'll be having a demo after that, and then limitations, like how far this can go and how potential can be exploited in future.
And yeah, we'll start off with why data quality is important. So according to Gartner report, generally they say that because of poor data quality, they are losing around $12.9 million per annum. So consider a scenario when the data is said to be a qualified data. Any idea? The data needs to be accurate, consistent, completeness, timely and relevant. So all these 5 features, 5 characteristics should be present on the data. Then only the data will be classified as a qualified data. Maybe we'll take an example. How you may surprise that how $12.9 million will lose because of poor data quality. Assuming that everyone has an habit of ordering online. Maybe it's a food or a let's take an e-commerce, a logistics company. So assuming that we are ordering something and that e-commerce has an outdated customer address, let's say. So what will happen is the package which we have ordered will be delivered to a faulty address, which leads to a frustrated customer experience and poor satisfaction. So this is one of the feature where there is no accurate information, and there is also another use case.
Yeah, so I'll be pretty much pissed off if my query or all my logistics things has been not passed to me. So that's because of a data quality issue, which their customer reputation will be dropping off, and that case they will be losing billions. Like, this is just he gave us like one single example. Imagine that's happening around India or around the world. So same going apart from logistics. Let's assume it's on healthcare sector. So we have been providing our informations, right? So let's come to our weight. So it's been calculated in two categories. One is pounds and then kgs. Some countries have it as kgs and some countries have it as pounds. So I assume you are having an international hospitals, right? They'll be using both of it. And assume, let's say a pounds is not being classified as pounds, but it went to kg or kg went to pounds. During that patient will be really on some critical situation based on it, because their diet changes and they're about to go through some surgeries or something. Everything will be changing. Let's see, assume they will be going through some anesthetic limitations that also depends on their weight. So these are like critical information that needs to be pinpointed, accurate with consistency. That could also be deviated if the data quality is not there, and if that could be ranging varying if our consistency and accuracy is missing out from our point of view. So that's where these things get impacted in cost as well as our reputations as well.
Yeah. So moving on to the next slide. So poor data quality can lead to. I believe that everyone would have watched the first test match of India and Australia in Border Gavaskar Trophy. So if you notice, in first innings, India scored 150. It was a kind of a bit depressing situation for all of us, because it was we expected more, but India was able to score 150. But we bowled well, and Australia, we were able to take Australia within 104. With a 46 runs lead, we were able to take 487 in the second innings with a Jaiswal great innings. And in one point of time, Australia were in 229 for 9. There is 1.5 days pending to play, and Australia need 305 runs to win. So from this situation, what was just forgot about the first test match. Just you are seeing this as a real-time example. What will be your prediction now? Who will win this match? India, right? But you can surprise that what is the Google prediction is. Australia's winning percentage is 0.5 percentage, and India's winning percentage is 0.1 percentage, which is lesser than Australia's thing, and draws 99.4. This completely made the prediction wrong. So this is an incorrect prediction, right? So this is one of the thing, and assuming that we don't know anything about cricket, let's say. So if someone is coming and asked to take decision based on this information, even what you will say, Australia will win this match. Either it will draw or Australia will win this match. So bias in decision making. And the next thing is, this has been trained on a huge, definitely this would have been trained, a huge instance is running in the back end. So this is a wasted resources. So this is one of the poor data quality can lead to these decisions. So moving on to the next slide.
So reverting back, so these are the preview we would like to give you, like how impactful it will be on our data and on our day-to-day market for our organizations and other sectors as well. Like what will be our losses when it comes to data being in a poor quality if it's been projected towards the, let's say, to overall viewers or like users. So now how to improvise it. Obviously we do have a lot of way we could improve our data quality by manually doing it ourselves through Python or Spark or other let's say languages, or use certain set of features. Today we will be covering about how we can utilize AWS Glue's data quality on implementing a seamless quality data. So that's why we get in here. This is our AWS Glue data quality we will be speaking of.
Yeah. So any idea when this AWS Glue data quality got released? Yeah, maybe I'll let you know. It was released on December 2022 reInvent, just 2 years back. So initially it was in a preview version. In June 2023 it was a globally available thing. As we know, it's completely managed. Since Glue is a kind of serverless and managed ETL thing, it's managed and serverless. and this is used to evaluate the quality of the data.
Apart from that, as I stated before, we can design our own framework. Let's assume Spark already has something called DQ framework. So that is more likely an open API. So what here Glue does is we're implementing that same structure in Glue, teaming up with Spark. At the same time, we're having a DQ framework built in AWS Glue. So that way, you don't need to go ahead and try to implement such logics. We can just utilize those logics as features and implement it in our data on our ETLs, or as I stated before, like on our ETLs, on our let's say warehouses or storages and everything, even to predict logics, assigning with models and as other characters. So that we can feature it in two ways. One is going to be data at rest, and one is going to be data at move. Let's discuss that in brief later on, but these are the two features we have to be focusing on if we are about to go with data quality in Glue.
Yeah, and also one more thing. Anyone heard about DQ framework before? So DQ is nothing but DQ stands for data quality. Previously, you may get a question here. For doing a data profiling thing, I can use a pandas. Why specifically a data quality thing required for AWS Glue? We can use pandas itself, right? Why do we need a Spark kind of data quality framework is required? Any idea? To handle with big data. That's the only simple answer. To handle with big data, we need a Spark kind of data quality tool is required. Luckily, AWS Glue took this DQ framework and integrated it as an AWS Glue data quality. That was one of the great thing. And moving on to the next slide. These are all the key terminology. Before moving into anything, we may need to understand what language we speak. Generally, we both from Tamil Nadu. When we come to Kerala, at least we know something to understand, to ask something. So similarly, if we are jumping into any new technology, we may need to understand some key terminologies to talk about. So we'll start with the first thing, DQDL. DQDL is nothing but data quality definition language. Generally, if you notice in AWS Glue data quality, we will be defining everything using this DQDL. So yeah.
Oh, okay, sorry. So yeah, that's going to be our language, which will be trying to specify our rules. So that's our second version. So the second, let's say, a feature we will be applying on. So what is a rule? Rule is, as you all know, that's going to be our set of let's say parameters that's going to help us to control the irregular data activities by applying such set of rules. So each rule on each data will be giving us a sector of field that will be helping us to avoid anomalies. So that rule is going to be implemented. So it could be a custom rule or it could be a set of rules.
Yeah,
so
for example, to give a more specific about rule, assuming that you are applying some rules on a file, let's say, you are getting an empty file. Doing processing on empty file is a waste of time. So you can apply some rule like row count greater than 0, which means that the row it will be processed only if there is a row. So this is an example of a rule. Maybe coming to the rule set. Rule set is nothing but a set of rules is called as a rule set. Just simply consider as an array. Array contains of multiple rules. That's a rule set.
And as for data quality, based on these set of rules and individual or set of rules, we will be going through that, let's say, logic where these set of rules will be implemented, orchestrated through the data, whether it's going to be a real time or it's going to be a branch version or it's going to be applied on our DBs. These set of rules will be following up with the data quality. It will be assuring each and every rules has been applied, and if the anomalies are present, we can move ahead and that will be on future slides what will happen. But data quality's purpose is to analyze, split them up, and then feature us the quality data to wherever the perspective we are trying to store in destination, and the rest of them will be eliminated in this particular set of feature, data quality.
And coming to the data quality score. Data quality score is nothing but assuming that I have 20 rules applied on a specific data set, out of which some of the rules got passed and some of the rules got failed. Let's say 19% of the rules got succeeded, 19 rules got succeeded out of 20, and 1 rule got failed, which is about 95% of my rule is passed and 5% of the failed. So that score is being calculated as a data quality score.
So based on that data quality score is what we stated like before, the data will be processed or not. And once it's been done, we will be having a quality set of data which can be utilized for analyzer. Analyzer is something will be giving us a rendered version of data that could be used for prediction analysis on AI models. They'll be giving us an analyzed version of, let's say, a dashboard. They'll be having us information on, let's assume we have a table of 50 rows or something that will be giving us, these are the quality data, this much anomalies have been found. It's more of an insight dashboard that will be presented us through analyzer.
Generally, to add up more points on analyzer area, analyzer is a kind of, let's say, this is used to specifically use to detect anomalies. Anomalies in the sense you can't find it on a single run. It needs to appear on multiple phases, and could be a ongoing data quality issue. Like it may not be hard to detect data quality issues. So these kinds of issues can be analyzed using analyzer. Generally, the behind the scenes ML algorithm is running behind the scenes to understand the anomalies and also the art to detect quality issues. And moving on to the observation. Observation is a kind of an unconfirmed insight. Let's say it's an insight actually. It's an unconfirmed insight. It will take the data from the analyzer. Analyzer will be the input for the observation, and it will understand where the data is going wrong. This will be help us to understand what observation we can make based on the analysis. So this is about the key terminologies. Just giving a pause for a couple of seconds. Any doubts on this till now? We are just jumping into next step of technical insights of AWS Glue data quality. Yeah, taking the silence as no, we are moving into the features of AWS Glue data quality.
Yeah, this is going to be serverless, so you don't need to really worry about trying to optimize it or trying to make sure that understand the data first and then try to implement the set of, let's say the nodes or like what it has to be having it to run this set of feature. So this feature does everything optimized version. That's why we call it as serverless. All we have to do is just provide set of datas, and that will be doing the rest of the services, which will be stating out like what are the other let's say features we can move.
Yeah, as mentioned, it is used to detect data quality issues. And just one question here: is a data quality a one-time activity? Yeah, it should be a continual approach. Even if we are setting up a pipeline, it needs to be a first time. Even during the first time, it needs to be set up, and it needs to be on a continual basis. So this is why it will always detect data quality issues. And based on the things, we may need to improvise our rules every time. So this is we can improvise the rules anytime we require. And
as I stated before, like rules can be improvised in sense that we can customize each and every of our rules. Customization comes first, and okay, I don't want to confuse that part. So we can customize our rules based on every set of implementations. As I stated before, like it can't be done in a single data quality session. It has to be running more than 1 or 2 to 10 times. And at point of time, we will be figuring out how many anomalies we are having, and based on that, we can customize each set of rules in data sets as well as in rules and rule sets as well. So in that case, these rules can be easily helping us in a way. We don't have to go with a fixed set of feature. In that case, we can just try to avoid that anomalies based on it. And pay as you go, like as everyone know, like how much ever we are using is going to be what we will be paying. So nothing much on that feature.
Yeah,
and
one thing with pay as you go feature is generally Glue cost is based on the DPU. We all know that DPU is nothing but a data processing unit. So similarly, as we mentioned, either we are doing in at rest or in transit, it will be a pay as you go. It is coming around some 4 cents, I believe, per hour for one DPU. Similarly, how much DPUs we are using and how many hours we are running. So that depends on that is pay as you go. And as we discussed, this is an ML based quality detection. Analyzer and observation are the key terminologies which we discussed in the previous slide, which is a kind of an ML based quality detection. Even though if we are applying the rules, this is going to, in the back end, it will be using an ML algorithm. And yeah, now starting with the first thing, data quality at rest. We can apply data quality in 2 things. If we have used Glue, there are couple of things available. Either we can configure a ETL job or we can create a catalog tables. So when creating a data quality at rest, let's say, assuming our data is on catalog table. What are all the things we can do with catalog tables? So first thing is, this is generally catalog table will use for data discovery purposes. What are all things available? And the main thing with data quality at rest is it will recommend our rules. It will understand the data and it will recommend the rules for us. What rules we can apply on the data. This will be a static approach, but we may need to improvise the rules. Instead of assuming that we don't have any idea about data, but registering on the catalog table and understanding it with data quality address will help us to understand the data and also what rules do we need to apply. This is one of the thing. And next thing is we can understand the data based on evaluation. Like since it is suggesting the rules, we can evaluate based on the thing. And also the last thing is we can integrate with APIs as well. We know that we all would have used Python. We can easily integrate with Boto3 APIs as well. So this is one of the API called what we can do with data quality.
So data quality at rest has two use cases. One is what he mentioned. We can plug and play with data and then get all set of rules recommendation, try to improvise our data quality one by one and then apply it on using Boto3 on other stuff. And also we have situation 2 is where you can use that qualified data and try to create models and try to let's say automate this process. So in that case what happens is we can have these qualified data being automated through any models we are trying to develop and processing them in secondary versions of it. So this is like two use cases. One is to identify and the second case is to deploy them in our models.
Yeah, moving on to the next slide. Data quality in transit. This is one of the crucial point. How many of them like we have multiple Gen AI session previously we had in this event, so we could understand while doing an ML task, a data profiling and data cleansing is one of the most important tasks in ML. When it comes to in transit, let's say we are just in what we will be doing in ETL job. We are extracting the data, transforming and loading into the destination. What if we apply data quality while doing in ETL? We can reduce the data cleansing work while doing the ML work. That is one of the crucial use case with this data quality in transit. And you may ask me, in data quality address the rules was recommended. Whether in transit will the rules be recommended? No, the rules will not be recommended here. There are couple of ways we can work with transit. One way is we can use a visual ETL to create a job, and second thing is we can directly play with the script. We can directly get into the script. We may need to import the necessary packages and we may need to call this evaluate data quality action. Generally, even if we are doing with visual ETL, we will be calling this action. So based on that, we will be doing the task. And it, as mentioned, we can write the logs to Amazon Cloud. Generally, if any ETL jobs fail or succeeded, the logs will be returned to CloudWatch. Similarly, same we can write it to CloudWatch, and we have a flexibility to write to S3 bucket. And one important feature with in-transit is we have a multiple options. Whether if data quality is not getting matched, let's say, we can fail the job or we can succeed the job. Maybe we shouldn't be loading the data and fail the job is one of the option, and we can load the data and notify the user about it, or we can just do we don't want to do anything, let it just loads, that's it. So this is the option provided by data quality in transit, and we can store the original data and also the data quality results to our destination. So this is we have a demo as well. We have demo screenshots as well in the upcoming slides. We will understand how it works actually.
In-transit mostly be used for live data stream, more real time and then near real time purposes. And this is going to be our like let's say trying to see how these things are differentiated between each other. So these are the features we would be assessing it with, like data source and data quality rules recommendation, auto scaling and everything. So as he mentioned, there are certain things that's been supported by in-transit and that's not been supported by let's say REST, and vice versa.
And to be more specific, if you notice data quality at rest and data quality in transit. In transit, we have flexibility to write a code. we can use any sources to the Redshift. We can create a connection using JDBC connector, and we can use that connection in transit. And when it comes to at rest, only S3, Redshift and JDBC sources are supported. We don't have an option to write a code over there. That is one of the thing. And coming to the rule recommendation, we even in the slides we seen that it is supported on at rest and it is not supported in transit.
Yes, so it's, yeah. And there are certain things both have been supporting, that's on CloudFormation logs.
And main thing is incremental data quality. When it comes to incremental data quality, anyone heard about Glue bookmarks? Definitely, yeah. Glue bookmark will be used for handling incremental data in transit. And when it comes to address, we will be using push down predicates. And coming to ML based anomaly detection, this is not supported at rest, and in transit it is supported. And cloud formation, generally we can deploy anything using cloud formation, even at rest or in transit. This is supported in both the versions. Yeah, moving on to the next slide. This is we'll start the demo with data quality at rest. So assuming that you have registered your table with your data catalog table, when you get into the table, you may notice something called data quality. So just clicking on data quality, moving on to the next slide, you will be getting into this specific thing. Here if you notice, you can see the create data quality rules. So when you click on create data quality rules, it will ask us to specify the IAM role and also the number of workers. This is the place the DPU is being set. And task timeout, I just kept it as default thing. And this is the place where we have seen about recommend rules. This will help us to recommend rule. If you notice, it will scan the data and generate the rule recommendation. So it will run for based on the data set size, it will run for certain amount of time, and it will recommend the rules. Moving on to the next slide. Yeah, if you notice, based on the rule set I provided, it has recommended 51 rules to me. So next thing, moving to the next slide. Yeah, these are all the rules it got recommended. So either I can select anything. This is a kind of an healthcare data I was playing with. So if you notice, what's the patient ID, what's the uniqueness, these are all some of the rules. If you notice, row count is one of the data quality rule, is complete, column values is unique. These are all some of the data quality rules. And I will be selecting few things what required to my use case. So moving on to the next slide. So I have just selected 4 things to my, this is actually a rule set. If you notice, this is my rule, and this 4 is comprised of a rule set, and this complete language is a DQDL, data quality definition language. So yeah, so once this is run, moving on to the next slide. If you notice, my rule set got created here. So I will be running my rule set here. So if you notice, the rule set got completed and data quality score is 100% because all the 4 rules got successfully passed. So my data quality score is 100%. Moving on to the in-transit, there are a couple of ways to work with in-transit. One is visual ETL and another is a script way. I prefer to play with code, so generally I use script mode. So one thing we may need to import is this evaluate data quality. This is the main import we need to do. This is an action as well. And yeah, moving on to the next slide. This is the rules I recommended. So if you notice, the data which I am getting should have 15 columns. If it is more than 15 column or less than 15 column, it should fail. And row count greater than 0. It shouldn't be processing an empty file. And also exam date. Exam date is nothing but when the patient took an exam. It should be between 5 years and 0, and these are all the columns should exist on the table. And always patient name should be complete. It shouldn't be null. So these are all the rules I recommended, and this is the place where I'm applying my data quality. So this is the frame. This is my dynamic frame where I'm applying my data quality. And what is the rule set? This is the rule set. I'm passing it over here, and where it needs to be, whether it needs to be populated on CloudWatch, and what's the S3 prefix should I use, where it should be there. So these are all things I will be doing. And moving on to the next slide. So in ETL job, I have this specific tab called data quality. So if you notice, out of 20 rules I have kept, 19 rules got passed. So my DQ score is 95%, statistics gathered is 4, and anomalies also it has found. So we can see rule statistics anomalies, more details over here. and for all the runs we can see this. So this is my data quality trend. So initially for the first 3 days, November 15th, it got passed, but on November 19th it got dropped down. How my data pattern is working, so I can understand that. And moving on to the next slide, and also I can see what all the rules got passed and which rule got failed. These things I can able to see. And even when we click on anomalies, whether do we need to consider anything about that, or even it will suggest us any action required from our end. So this is about the data quality in moving on to the next slide. Yeah. Yeah.
So as we were stating before, these were limitations. So okay, before moving to limitations, so when we were showing you like these are the data qualities, anomalies, and every statistics, wouldn't you have any questions like how we could identify which data failed or which file failed? Like how would be trying to get that out? Or like how could I be identifying which file failed or which set of table failed when it's trying to check the data quality? How could we get through that? Do you guys have any suggestions or something like that? Because we were seeing how things could be implemented, and this is how a successful play does. What if it fails and where it failed? Like, what is the way we could try to interfere with that? So that's where we could use our Bodo versions to capture those logs. I mean, as he mentioned, it's been capturing on our CloudWatch logs. So we are still plugging and playing on that part, but we can actually set up another control table where we can, let's say, extract which table or which file failed, and so that we can have a clear, better understanding on where it failed. Because this will be showing on which column failed and which value failed. Not even column, which value failed. But we need to know which column it failed with and which file it failed with, like the source file. Those source informations can be gathered up through CloudWatch and dropped into our customized own, let's say, control tables or something like that. And apart from that, these are the, as I said it before, like limitations. Structure and list types, as of now, they are not supported by data quality. Maybe in future that can also be implemented. And as for the rule set size, we can't recommend, as you saw the recommended rules, that can't exceed more than 65 KB. So
and yeah, one thing is with regards to nested struct or list type, let's say we are playing with the JSON data. Let's say we may encounter with a list or struct type. We face this situation actually. How we handle this scenario is maybe this is one of the practice we followed. Flatten everything. If we are getting a JSON data, flatten everything to a single key value pair. Then apply this data quality rule. This is how we overcome this limitation. And also we never encountered the 65 KB limitation actually. Even if we are able, if we need to exceed 65 KB limit, we need to have 2000 rule set, 2000 rules in a single rule set. It is hardly, I don't believe we will be writing 2000 rules in a single rule set. So I believe that the first thing we can handle via the flattening part, and next thing we won't be encountering such scenarios. Even if we are encountering, we may need to break the rules actually. Rule set 1, rule set 2, if we are breaking this up, we can overcome this scenario as well.
And the flattening part can also be done by a dynamic frame as well, instead of our Python scripts too. So that's not mostly a limitation, it's more like a precaution we can take upon it.
Yeah, and this is the place you can see what are all the things we discussed today. So you can, this is a blog which was written by us, and you can see the entire thing what we have discussed now. Maybe the peoples are capturing, I think. Yeah, moving on to the next slide. And any question? Maybe question. I'm eager to get questions. Yeah, exactly. When it comes to AWS Glue data quality, there is a specific rule called data type match. So assuming that you are getting an integer, let's say, but it is been classified as string in Glue. So you can check data type match, the column name, and it should be int. If it is failing that specific rule, you will be notified automatically. So you can configure that rule as well. Yeah, thank you. And any other question?
So is it likely the problem with the data or the rule, like the way you configured the rule?
Actually, what I did is I intentionally failed that specific thing actually. The column doesn't contain ID as a column, but I intentionally passed column exist ID. So that column was not exist on that specific file. So it got failed. So since it was a manual made error, I was able to infer it actually. But when it comes to the actual use case, even we can fail that specific thing. As mentioned, we have an option to stop the data load too if it is not matching the criteria. So we will be notified even in that case. Yeah.
Rules are mostly booleans. They give a true or false option. So whatever the data is acting, that nature can be specified in a true or false manner. So if it's failing, then that's a false flag, and if it's passing, it's a true flag.
Yeah. Okay. Okay. And next, yeah, this is our LinkedIn. You can connect to us if you are encountering any data quality, or if you are setting up any glue related things, you can feel free to reach out to us. Even if you are interested to share about your glue interesting stories, we are pretty much working with glue for the past 4.5 years, I believe. So we almost I believe that even with the new announcements, we are trying to play with glue with all the most glue announcements. Even if you have some interesting story, even we are interested to hear from you all. Yeah. Okay, thank you so much for listening patiently, and even we will be here. You can reach out to us if you have any questions. Yeah, thank you so much.
Thank you, Arun. Thank you.